All right, welcome back. We're going to talk about initial value problems. So all an initial value problem is it's a differential equation together with an appropriate set of initial conditions. Okay, so if you have, let's say, f of x, y, y prime to the nth derivative of y equaling 0, then you're going to have, in this case, this is an nth order differential equation. So you're going to have n initial conditions. So typically our initial conditions are going to be y of x0 equals y0. So this is assumed to be given. And then you just have, actually n minus one of these. Okay, so actually, since this started counting at 0, this is how you get n conditions. Okay, there's already 2, and you can see you would get n conditions. All right, so there is a big theorem about this. I'll just write it down. Okay, if we consider dy dx equals f of xy, okay, with y of x0 given, so this is an initial value problem, okay, if f and the partial of f with respect to y are continuous in a rectangle, okay, r equaling xy such that a is less than x less than b, c less than y less than d, then, sorry, x0, y0 being in our rectangle, okay, then the initial value problem, that's this thing, okay, has a unique solution phi of x, let's say, on some interval x0 minus delta, x0 plus delta, where delta is just some number bigger than 0. Okay, we're not really going to do too much with it. I just want to put it out there just for completeness. Okay, but let's go ahead and actually solve an initial value problem. This will be our first initial value problem. Okay. So let's solve. And actually in the book, the question is verify this is a solution and then find the solution for C1 and C2, but we'll go ahead and just solve it. So we're going to solve d2y dx squared plus dy dx minus 2y equals 0. Okay, so this is linear, second order, and homogeneous. Okay, and the way that we actually looked at this before, the way that I mentioned that we're going to solve this before, is we're going to assume that y equals e to the mx. and then we're going to get a quadratic and solve it. So let's do that. So if y equals e to the mx, y prime equals m e to the mx. Oh, sorry, forgot something. Forgot our initial conditions. Y of 0 equals 2. Y prime of 0 equals 1. So what's this saying, these initial conditions? We need 2 of them because it's second order. Okay, it's second order, so we need 2 initial conditions. Sorry about that. Okay, so let's go ahead and finish solving this. So we assumed y equals e to the mx. Y prime is then m e to the mx. So y double prime is m squared e to the mx. Okay. So we get m squared e to the mx, that's the y double prime term, plus m e to the mx, that's the y prime term, minus 2 e to the mx, that's the y term, equaling 0, right? In fact, let me make these arrows nicer. The y double prime term goes there. The y prime term goes there. The y term goes there. Okay, so factoring out the e to the mx, m squared plus m minus 2 equals 0. This, of course, factors m plus 2 times m minus 1 equals 0. So m equals -2 or m equals 1. Okay, so our general solution, this is before we do the initial conditions. Our general solution is going to be y of x equals c1 e to the x plus c2 e to the -2x. Doesn't matter which one I choose to be c1 or c2. Okay, now let's go ahead and solve those initial conditions. So y of 0 equals 2. What does that tell me? If I plug 0 in for x, I'm going to get, this just gives me c1 plus c2. Okay, because e to the 0 is 1. Okay, y prime of 0, let's take y prime of x. Y prime of x is going to be c1 e to the x minus 2c2 e to the -2x. Okay, I'm going to play a little game here that I do. Make some more space, and then I'll size it back later. Okay, so y prime is again c1 e to the x, c minus 2c2 e to the -2x. And our initial condition, I'm going to need to make that a little thinner, is y prime of 0 equals, let me see what that was again, 1. So that means that c1 minus 2c2 equals 1. Okay? So from here, I can solve for c1 and c2. All right? So adding, taking 2 times row 1, plus row 2, that gives me 2c1 equals, sorry, 3c1, okay, because the c2s are going to cancel, equals 4 plus 1 is 5. So c1 is 5 over 3. Okay. That's one elimination. Let's move that over here. The other elimination, eliminating the c1, I'm going to take row 1 minus row 2. Okay, and if I do that, I'm going to get c2 plus 3c2 equals 1. So c2 equals 1/3. So my total solution then becomes y of x equals 5/3 e to the x plus 1/3 e to the negative 2x. Okay? All right, I'll see you guys in the next video.